Well, a recent video from 0710 Jack inspired me to do another Trivector video. This Trivector was given to me a while ago, but I haven't done a video with it yet, so I'm gonna set it up, connect it up and see if it works. Well, here we go. The Trivector is connected. Vaguely I remember this thing came from Pi Airbase, I think, yeah. So again, we got Trivector, and this one is 110 volts as well, so kilowatt hours. It's a blank 5 meters, 3 times 5 to 5 ampere, 11,210 volts, and kVArh register has more or less the same specifications. So the meter rates 2 units for 110 volts, 11,210 volts, and an additional multiplier of the CT ratio will be added to the meter. I'm going to clean this thing up a bit and then, yeah. Okay, the meter is clean-ish. Voltage is here on the voltmeter 111.2 volts, furnished by this little transformator here. And I got a temporary current source, a rough wind MOT transformator. I'll get some close-ups on the dials. This is the kilowatt hour dial, which runs at a reasonable speed. The load is about 5 ampere, 5.7 ampere. Single phase supply, hence 120 degree phase shift. The kVAh hour register has no disk. That's calculated from the kWh and the kVArh register, so the mechanical gearbox. This is continuous demand, and on the top register is a peak demand, which is registered over particular time slots, usually between 5 and 7 at night. This is the reactive register, kVArh sign, so that's components on the reactive which you normally try to compensate for with power factor capacitors. Voltage is 111.19. Hope this is readable. This was the nameplate from the kVA component of the meter. I hope it's not too shiny. Made in Great Britain. I'm going to take the cover off and I'll have a look in the inside of the device. Okay, quick inter-tim reading. I've been playing some Minecraft, and yeah, this is reading at the moment. Again, these Landis and Gyr meters are pure pieces of art again. Let's have a look at this. Mirror discs, 2 disc meters, red and blue element driving, and the gearboxes for the maximum demands, and this is the kVArh meter, 2 disc meter as well. This is really engineering at its best if you look at this. This is upside down footage. I'm not sure how well visible this is going to be. Just hold the camera underneath the calculating gearbox basically, and I'll see how well it picks it up. I've activated all the external terminals as per the schematic, and this is just the lower standard terminals in here. All Trivectors generally are wired up differently, so I'll just go by what was written in the terminal cover by one of the previous test technicians who connected this meter or pre-commissioned it. Simply beautiful to look at these devices. Not sure how well again all the pieces are visible in here. Again, opening up one of these old meters, that gives that lovely vintage aroma. Very nice. Bakelite, fibers, etc. Interesting pattern we got on this disc. Good old induction meter. All metallic gear train. Number wheels, metal, aluminium. Okay. These Trivector meters has an external reset button, and I'll see if this one works. I'm not too sure, so I'm going to push this device here. See if we get some action on this meter. So that will energize these motors here on the side, and they're on their way. There you go. Setting the NDI dial, and then the cumulative register will be advanced at the same time as well. Oh, the bottom one was sticky, that didn't reset. I'll push the button a bit longer, see what happens. Sometimes I get sticky and you push the button for a few seconds. You got a couple of these devices, they're massive, the same size as your hand. Just unbelievable. They're coming out of bulb. So this is device 1. Oh, it's a duo cap, so it's a biflower or whatever you want to call the device. It looks really cool. Still waiting for my wasps, but we'll get them eventually. Well, I've tidied up the wiring a bit on this meter at the moment. It looks a bit better and it runs a lot faster. I'll tidy that part up. And we get a quick wall over here, may as well enjoy that, how it goes. 435199, rolling over slowly. This is what the full speed would be on this meter at a healthy load of 5 ampere. That's the kWh side. The load on the meter is about 5.4 amperes. And we go to the kVArh side, which is here. Okay, the phase shifts, I'm not too sure what the power factor is. It's probably about 0.8 or something. Let's not worry about it too much. I'll make an attempt on getting the dial plate of this meter so we can have a close look at gearbox. 5.37 ampere at 50 Hz, so that's all good. I'll still do another aerial view because it's just such an enjoyment to watch these meters. And I'll probably go through the wiring a little bit for meter collectors who may have some of these Trivector meters or just want to connect it up to a phantom load or normal load and let the disc spin, because meters need to be running, not sitting stationary. It's a lot more fun when the dials are moving and everything is just active. Well, the dial plate has been removed, and now we'll see if we get a bit better access to the actual gear train. I'll do my best, whatever I can get out of here. I hope it's gonna record, because I can't actually see not much from here, because the camera is hanging underneath the meter and I can't see the dials. Let's hope it's gonna capture the information of this beautifully designed meter. And I'll get a shot from here. I'll just let the camera roll and I'll edit it to suit. This is a 30 minutes timing motor, just a little bit of a different angle. kVAh register dials. Some of the differentials, I'm not sure you can see them move, but they should be slowly turning. Absolutely stunning. It's the sun wheel of one of the gearboxes. You can see the anti-creep vane. Oh, we had a reset here, that's cool. And there's also a reverse running stop here somewhere. So you get a better shot of that. There's some vane here. The meter can't go backwards. And reverse running stop here. I've fixed the reset mechanism, so hopefully it works. This meter has been running at about 0.8 power factor. As you can see, the kVA, both of these dials are engaged, is reading higher than the kilowatt hour. Because of a lagging power factor, there is a reactive component on the power usage. So that register has recorded a certain amount, hence the kVAh, or the maximum demand, is higher than the kilowatt hours. I'm going to reset the device now. See if it's going to behave this time. See the two little push needles, they just drop down and both arms come back. This meter had been sitting for the last 24 hours at about 5.3 ampere, so it's fine. It's well within the meter's rating. I'm going to show you the wiring diagram shortly. Also how to connect one of these. I got them running on full speed, this meter, so I got both elements in series. I'll just put the camera a bit closer. Stand by. The way I've wired this meter up is, again, potential calls is important, 110 volts. So I got from this transformer, this is the feed-in, red, the other one is the yellow, white, the 110 volts. What I've done, this is my common one. I also have activated the blue phase. Basically they're the same as the red potential, so there's a little jumper here between the red and the blue. So I got this as my midpoint, the white or the yellow wire, and the red and the blue on the same phase. With the current, to get 5 amps on each metering element and double the speed, or the meter sees 10 amps, 5 amps on each element. Current in from the plus minus of the source, series go out into the blue, current calls comes out to the black wire, return back to the source. Hence the meter runs at quite a nice speed. Okay, here we close up on the disk speed at 2 current elements in use, 5 ampere each, 5.02 ampere. Well, I've removed the blue element from the system. I'm going to energize. So now the meter runs on one element, and we got green wire leading in, red current, and the black wire out is blue. And here we got the meter running on one element, 5 ampere. So it's a lot slower speed wise. On my temporary phantom loading, I just rewound a microwave oven transformer, just rough 2.5, probably about 20 turns, 240 volts on the main, but controlled by Variac. So this is just controlled up here, and I got the Variac sitting up here at the moment. That sits up here on the top. And the input voltages are maybe 10 volts or 15 volts, because I need to monitor my current on this device. So yeah, this is just an 8 ampere Variac basically, which controls this to manage my current, to test the meter. Very simple to make. You need higher currents. You put 16, 25 mil, couple of turns, but you need to control your 240 volt coil by means of a Variac. This particular Trivector meter has some side terminals. I've jumpered these out as far as needed. One particular jumper is to get the peak demand register energized, and the red and yellow at the bottom part is for the clock motor 30-minute device. So yeah, this was the Trivector, maybe video Trivector number 4 or 5, I've lost count. Still got another 6 or so Trivectors which I want to do. In the future, one of these Trivector meters has a pulse initiator card in it, and it may still work, so I'm going to see if I can connect it up to some meter or something. Thanks for watching, hope you enjoyed this video.